Yes.
Hello students, good morning. Welcome to this class. Today I'm going to start the new unit, that is the fourth unit, which having two parts. Part one having the vapor absorption refrigeration system, and part two we have non-conventional refrigeration systems, that is steam jet refrigeration system, thermoelectric refrigeration system, vortex tube refrigeration system. These three are under part two of the unit 4. This is part one of unit 4 is vapor absorption refrigeration system, VAR system. It is shortly it can be called as VAR system. Till now we discussed the VCR system, isn't it? In unit 3, the components in VCR system. In unit 2, the working and the types of cycles, types of VCR cycles, that is vapor compression cycles. Clear? So this is the VAR system. It is the oldest system when compared to the VCR system. In this VAR system, mainly the main difference between these two is the input for the VAR system is heat energy in place of work energy as in VCR system. VCR system లో మనం వర్క్ ఎనర్జీ యూజ్ చేసుకుంటాం, అంటే పవర్ సప్లై చేసి వర్క్ ఎనర్జీ ఇన్పుట్ గా యూజ్ చేసుకుంటాం. In VAR system, the system runs by the heat energy. So to produce the refrigeration effect, the VAR system utilizes the heat energy. As we know that in thermodynamics, we studied that the heat energy is the low grade energy when compared to the work energy. Work energy is the high grade energy. So this heat energy, low grade energy, can be produced and having the less cost when compared to the high grade energy. Okay, the VAR system utilizes the heat energy, which having the low cost and the low grade energy is. The only difference is it utilizes that is the heat energy. So another difference is in the VCR system having the compressor to pressurize the refrigerant from low pressure to high pressure. But in place of compressor, the VAR system consists of 4 main components, that is the absorber, generator, pressure reducing valve, and pump. These are the 4 another devices which are used in place of only single compressor. Clear? In olden days, the VAR system used in 1824, it can be, that is the first discovered by Michael Faraday in 1824. Let us go for the introduction. VAR system, vapor absorption refrigeration system. The vapor absorption refrigeration system is one of the oldest methods of producing refrigeration effect. The principle of VAR system was first discovered by Michael Faraday in 1824 to liquefy certain gases. The VAR system is used in both domestic and large industrial refrigerating plants. The refrigerant is commonly used in VAR system is ammonia. Ammonia is one of the best refrigerant which is used in VAR system, which is developed in 1824. Nowadays, we are using VCR systems, but in olden days, this VAR system is most useful whenever the power is not available or power is very expensive, it can be useful. The vapor absorption system uses heat energy, that is heat energy instead of mechanical energy as compared as in VCR system, vapor compression system. Vapor compression system mechanical energy use cheskoni work avutundi, but VAR system heat energy use cheskoni work avutundi. Okay. In order to change the condition of refrigerant in the cycle of condition of the refrigerant change cheyadaniki heat energy is very useful in VAR system. In VAR system, the compressor is replaced by an absorber, a pump, a generator, and a pressure reducing valve. These are the 4 devices which are installed in VAR system in place of compressor. remaining three parameters, the three components are same as that of the VCR system. What are the three components, remaining three components other than compressor? Condenser, expansion valve, and evaporator. These are the three devices which are same as that of the VCR system, but in place of compressor, another four devices are there in VAR system: absorber, a pump, generator, and pressure reducing valve. These four devices, these absorber, pump, generator, and pressure reducing valve combinedly functioned as that of the compressor in VCR system. Same function as that of the compressor. These components in VAR system perform the same function as that of the compressor in VCR system. In this system, the vapor refrigerant from the evaporator, is drawn into the absorber. But in VCR system, from the evaporator, the vapor refrigerant is drawn by the compressor. But in VAR system, the vapor refrigerant is entered into the absorber. Absorber is the storage device in which the absorbent, one of the fluid, which is absorbs the refrigerant coming from the evaporator. Evaporator నుండి వచ్చిన refrigerant ని absorber లో ఉన్న absorbent అనే liquid absorb చేసుకుంటుంది. Okay, to convert into liquid. ఇది vapor state లో ఉంటుంది evaporator నుండి వచ్చేది. దాని liquid state లోకి కన్వర్ట్ చేసుకోవడానికి ఒక absorbent యూజ్ చేసుకుంటాం. Where it is absorbed by the weak solution of the refrigerant, forming a strong solution. Refrigerant weak solution absorber లో ఉంటుంది. Absorber లో ఉన్న weak solution ఈ అమోనియాని అదే refrigerants vapors ని absorb చేసుకోవడం వల్ల that will becomes a strong solution of refrigerant. Strong అంటే ఎక్కువ amount of refrigerant ఉంటుంది దానిలో. This strong solution is pumped to the generator. పంప్ యూజ్ చేసి జనరేటర్ కి పంప్ చేస్తాం. పంప్ చేస్తున్నప్పుడు దాని ప్రెషర్ ఇంక్రీజ్ అవుతుంది. ఓకే, we can pump the liquid but not vapors. That's why we are converting the vapor coming from the evaporator into the liquid by absorbing in the absorber. That liquid is pumped to the generator using a pump where it is heated by some external source. Generator is the device in which the heat is supplied by the external source. Okay, the strong solution which is pumped to the generator is heated by the external source. During the heating process, the vapor refrigerant is driven off by the solution and enters into the condenser. ఏమవుతుంది, మన జనరేటర్ లో హీట్ సప్లై చేయడం వల్ల vapor refrigerant, again refrigerant will be vaporized by absorbing the heat and that is driven off by the solution. Weak solution అనేది separate అయిపోయి vaporize అయి కండెన్సర్ లోకి ఎంటర్ అవుతుంది. కండెన్సర్ వేర్ ఇట్ ఈస్ లిక్విఫైడ్. కండెన్సర్ లో మళ్ళీ అది లిక్విఫై అవుతుంది. ద లిక్విడ్ రిఫ్రిజిరెంట్ దెన్ ఫ్లోస్ ఇంటూ ద ఎవాపరేటర్ అండ్ సైకిల్ రిపీట్స్. ఆ లిక్విడ్ రిఫ్రిజిరెంట్ మళ్ళీ ఎవాపరేటర్ లో ఫ్లో అయ్యి heat will be absorbed in the evaporator and cycle will be repeats. Like this, the VAR system works. In this, we are using two fluids. Two fluids are using, one fluid is act as a refrigerant, another fluid is act as an absorbent. Okay, absorbent ఏం చేస్తుంది, it will be absorb the refrigerant coming from the evaporator. Absorb the refrigerant coming from the evaporator. So we are using two fluids, one is absorbent, another one is the refrigerant. Refrigerant is flows across the cycle, but absorbent is not flows across the cycle. Absorbent is flows across the generator, pressure reducing valve, absorber and pump. The cyclic process, total cyclic process, the refrigerant will be flows, but partially the absorbent is flows in the system. Let us look for that desirable properties for refrigerant and absorbent. What are the properties required for the refrigerant which are used in VAR system and absorbent? So for a good refrigerant, positive vapor pressure is required. Positive vapor pressure means the pressure in the evaporator must be that is the below atmospheric temperature, that is above atmospheric temperature. Positive vapor pressure required to avoid the leakage from the evaporator to the atmosphere. Okay, Positive vapor pressure is required. High enthalpy of evaporation. High enthalpy of evaporation ante ఇది already మనం refrigerants topics చదువుకున్నప్పుడు that I explained in thermodynamic property. It is a thermodynamic property, high enthalpy of evaporation or high latent heat of evaporation. The refrigerant must have the ability to absorb the heat at evaporator pressure. Then only the high enthalpy of evaporation is high. Then whenever the high enthalpy of evaporation, the refrigerant having this property, it produces more amount of refrigeration effect in the system. High critical temperature and pressure. The critical temperature and pressure is the peak temperature and pressure, which must be high value when compared to the operating temperature and pressures. Low specific heat. In absorbing the sensible heat, the refrigerant having the low specific heat to rise the temperature. It absorbs low specific heat and refrigerant ki specific heat takkuga undali. Specific heat absorb ante heat absorb cheskunnappudu dan temperature anedi takku rise avvali. Okay, so low molecular weight. Specific heat ante again I will explain. Specific heat ante entante heat absorbed by the refrigerant per unit degree centigrade rise and per unit mass. This is a specific heat. ఇది తక్కువగా ఉండాలి అంటే స్పెసిఫిక్ హీట్ తక్కువగా ఉండాలి అంటే టెంపరేచర్ ఒక యూనిట్ టెంపరేచర్ రైజ్ అవ్వడానికి తక్కువ హీట్ అబ్జార్బ్ చేసుకోవాలి అంటే రిజెక్టర్స్ హీట్ అబ్జార్బ్ చేసుకుంటే లో స్పెసిఫిక్ హీట్ ఉన్నట్టు. ఓకేనా, టెంపరేచర్ అనేది పర్ పర్టికులర్ టెంపరేచర్ రైజ్ అనేది ఎక్కువ జరగకూడదు. ఓకే, లో మాలిక్యులర్ వెయిట్. Low molecular weight and the weight of the refrigerant must be low to flow across the system. Chemically stable. It must not react with the absorbent. The refrigerant must not react with the absorbent and also which must not react with the lubricating oil contained in the compressor. So it must be chemically stable. High affinity for the absorber at lower temperature. Takko temperatures daggara ee absorbent to mix ayipoye gunam undali. Okay, physically it must be mixed with the absorbent. Affinity means high affinity for the absorbent means it must be mixed with the absorbent at lower temperatures. These are the properties required for the good refrigerant in the VAR system. Then absorbent means this is the fluid which absorbs the refrigerant at lower temperatures. This absorbent must be required these four good properties. High boiling point. The boiling point must be above the refrigerant. Refrigerant kante boiling point ekkuva undali because whenever we giving the heat to the solution, strong solution in the generator, the refrigerant must be evaporate first. Okay, it must not be evaporate. Absorbent anadi evaporate avakudadu. Eppudu evaporate avadadi boiling point ekkuva unnappudu. Clear? So then low viscosity. Viscosity must be low to a flow across the system. System lo flow avvadaniki low viscosity undali. This property must have for the refrigerant also. I did not the list here, but low viscosity is also property for the refrigerant. High specific heat. Specific heat ekkuva undali. Deniki low specific heat is required. Then high specific heat is required. Endukante ఇది టెంపరేచర్ తొందరగా రైజ్ అవ్వాలి. టెంపరేచర్ అనేది హీట్ అబ్జార్బ్ చేసుకొని తొందరగా రైజ్ అవుతేనే ఎవాపరేట్ అవుతుంది. ఇది తొందరగా టెంపరేచర్ రైజ్ అవ్వకూడదు. సో టెంపరేచర్ డిఫరెన్స్ మస్ట్ బి హై. దట్ ఈస్ టెంపరేచర్ అనేది తొందరగా రైజ్ అవ్వకూడదు అంటే లో ఉండాలి. దట్ ఈస్ Q డివైడెడ్ బై CP Q డివైడెడ్ బై M ఇంటూ డెల్టా T. దిస్ ఇస్ ద CP దీనికి ఎక్కువగా ఉండాలి. హై స్పెసిఫిక్ హీట్ మస్ట్ బి రిక్వైర్డ్ ఫర్ ద అబ్జార్బెంట్ బికాస్ బై గివింగ్ ద హీట్ the temperature rise is very low. Temperature rise low ga untene specific heat high ga untundi. But refrigerant ki temperature difference anedi temperature rise anedi ekkuva ga undali. Temperature rise ekkuva ga unte tondaraga evaporate avutundi adi. Okay, so that's why specific heat is low for this, specific heat is high for this. And chemically stable, which is also chemically stable, which should not react with the refrigerant and lubricating oil chemically. Clear? These are the properties of refrigerant and absorbent which are used in VAR system. So let us go for the actual working of VAR system. This is the working of simple VAR system. Simple means it's having a desirable components. That is essential components matrame use chestam. To increase the performance, some other components are required for this system. So this is a simple VAR system. Once again, go through the this diagram. In VCR system, we have condenser, expansion valve, and evaporator. These three components as that of the VCR system, same as that of the VCR system, but in place of these, compressor is there in VCR system. In place of compressor, in VAR system, these four components are replaced. These four components are absorber, pump, generator, and expansion valve. Clear? This total four components combinedly called thermal compressor or thermocompressor. This is called the thermocompressor because combinedly these are perform the same function as that of compressor in VCR system. But this compressor is combinedly these are why this thermal compressor, why these four components are called the thermal compressor means this total devices which are run by the heat input. We are giving heat input to the generator. That's why it is called the thermal. By using the thermal energy, that is the heat energy, it will be works. It will be compressed or it will be raise the pressure from evaporator to condenser. So these four components perform the same function as that of the compressor in VCR system. Okay, absorber, pump, generator, expansion valve. This is a pressure reducing valve. It is also an expansion valve. Okay, pressure reduce chese valve. Range arutundi then function etante the evaporator by absorbing the heat from the required space to be cooled. Ee space naithe manam cool cheyalo, ee product naithe cool cheyalo, కూల్ చేసే ప్రోడక్ట్ నుండి హీట్ అబ్జార్బ్ చేసుకుని ఎవాపరేటర్ లో లిక్విడ్ రిఫ్రిజరెంట్ ఎవాపరేట్ అవుతుంది, వేపరైజ్ అవుతుంది. ఓకే, దట్ వేపరైజ్డ్ రిఫ్రిజరెంట్ విల్ బి సెంట్ టు ద అబ్జార్బర్. అబ్జార్బర్ ఇస్ ద స్టోరేజ్ డివైస్ ఇన్ విచ్ a liquid will be stored, that is the absorbent will be stored. Generally the absorbent is water and the refrigerant is ammonia. Okay, this is a simple ammonia water system. Simple ammonia water system. Ammonia having act as a absorbent here. Water is act as a absorbent. That water will be stored in the absorber. That water will be stored whenever the ammonia vapors comes to the absorber. That ammonia will be mixed with the water. That will be mixed with the water physically, and that vapors are converted to the liquid by mixing the water. Okay, the water having the high affinity to absorb the ammonia. That's why water is used as an absorbent here. Okay, after mixing the ammonia vapors into the water, that is a liquid state water, the total mixture is called the strong solution. Okay, the ammonia percentage is more, that's why that solution is called the strong solution. That strong solution, liquid state solution from the absorber is pumped by using a pump. This pump required for some work input. This pump required for required some work input. We should give the work input to the pump, but the work input to the pump is very less when compared to the heat input to the generator, and also work input to the pump is very less when compared to the work given to the compressor in VCR system. That's why here the pump work can be neglected. Clear? So by pumping the solution, that is the liquid state solution from the absorber to the generator, the pressure will be increases by the pump. The high pressure strong solution will be sent to the generator. This generator, steam generator, it is also called the steam generator or generator. In this generator, we are giving the heat input to the generator. By giving the heat input from the external source, this solution, this strong solution, from this strong solution, the ammonia first evaporates, because ammonia having the less boiling point when compared to the water. Okay, that's why the property of the refrigerant, one of the property of the refrigerant is the refrigerant having the low boiling point when compared to the are absorbing. So water kante ammonia takwa boiling point untundi kabatti first ammonia vaporize avutundi ikkada heat input ivvadam valla. Okay, ante in the generator from the strong solution the ammonia vapors are driven off or separated. Ammonia vapor separate అయిపోయి the water will be remains in the liquid state. ఇక్కడ వాటర్ అనేది liquid state లోనే ఉంటుంది. That liquid state weak solution, that weak solution అంటాం, that weak solution again comes back to the absorber through the pressure reducing valve. ఇక్కడ ప్రెషర్ ఎక్కువగా ఉంటుంది, అగైన్ ప్రెషర్ రెడ్యూస్ చేసుకొని అబ్జార్బర్ లోకి వచ్చేస్తుంది వాటర్. సో వాటర్ ఈజ్ రెడీ టు అబ్జార్బ్ ద నెక్స్ట్ సైకిల్ రిఫ్రిజిరెంట్. ఇక్కడ నుండి వచ్చే అమోనియా వేపర్స్ ని అబ్జార్బ్ చేసుకోవడానికి మళ్ళీ ఇక్కడ ఇట్ ఈస్ వెరీ రెడీ ఇన్ ద అబ్జార్బర్. ఇట్ ఈస్ రెడీ ఇన్ ద అబ్జార్బర్. ఓకే, సో ఆ విధంగా వాటర్ ఇక్కడ నుండి ఇక్కడ వరకే సైక్లిక్ ప్రాసెస్ లో రన్ అవుతూ ఉంటుంది. ఓకేనా, సర్క్యులేట్ అవుతూ ఉంటుంది ఇక్కడ. బట్ అమోనియా అనేది మొత్తం సైకిల్లో సర్క్యులేట్ అవుతూ ఉంటుంది. అమోనియా ఇస్ ద రిఫ్రిజిరెంట్. సో అమోనియా ఎప్పుడైతే వేపర్ ఫామ్ లోకి వెళ్ళి సపరేట్ అవుతుందో దట్ వేపర్ ఫామ్ లో ఉన్న అమోనియాని హీట్ రిజెక్ట్ చేసుకొని, అంటే వాటర్ కూలింగ్ మీడియం ఇక్కడ యూజ్ చేసుకొని లిక్విడ్ స్టేట్ లోకి కన్వర్ట్ చేసుకుంటాం. అమోనియా హ్యావింగ్ ద హైయెస్ట్ ప్రెషర్ విచ్ విల్ బి కన్వర్టెడ్ ఇన్ టు ద లిక్విడ్ స్టేట్ ఇన్ ద కండెన్సర్ బై రిజెక్టింగ్ ద హీట్ టు ద కూలింగ్ మీడియం. ఓకే, కండెన్సేషన్ ప్రాసెస్ జరుగుతుంది ఇక్కడ. So after condensation, the liquid ammonia will be entered into the expansion valve to reduce the pressure. Along with the pressure, the saturation temperature is also reduces. Okay, pressure reduce చేస్తున్నప్పుడు then saturation temperature కూడా reduce అవుతుంది. So liquid ammonia will be expanded in the expansion valve. After expansion valve, the state of the ammonia is in wet region, as already stored in the VCR system. During expansion process, due to the friction, the sum of the liquid refrigerant will be converted into the vapors. Okay, remaining liquid ammonia will be entered into the evaporator. The liquid only having the ability to absorb the heat. So the wet vapor will be entered into the evaporator. In evaporator, the liquid ammonia, which having the low pressure and temperature, absorb the heat in the evaporator to convert into the vapors. Again, that vapors are absorbed by the water in the absorber. The cycle will be repeated. Clear? Like this system will works. Clear? ఇక్కడ మనం వర్క్ కంప్రెసర్ యూజ్ చేసే బదులు ఈ 4 కాంపోనెంట్స్ యూజ్ చేసేవాళ్ళు ఓల్డెన్ డేస్ లో. సో ఈ 4 కాంపోనెంట్స్ ఏంటి? మేజర్ గా హీట్ ఇన్పుట్ ఇస్తాం. ఇన్పుట్ హీట్ అనేది ఇన్పుట్ గా సప్లై చేస్తాం. సో ఇన్పుట్ ఈజ్ హీట్, అవుట్పుట్ ఈజ్ రిఫ్రిజరేషన్ ఎఫెక్ట్ ఈజ్ ఆల్సో హీట్. క్లియర్? సో హియర్ రిఫ్రిజరేషన్ ఎఫెక్ట్ అంటే అదే COP ఎలా క్యాలిక్యులేట్ చేస్తాం? ఇక్కడ COP ఈజ్ the refrigeration effect produced in the evaporator divided by, in place of work input, we should apply the heat input. So work input badlu heat input తీసుకుంటాం ఇక్కడ. Measure the heat input. Of course, the pump absorbs some work input, but it's very negligible value when compared to the heat input. Okay, సో ఇక్కడ మనం ఏం చేస్తున్నాం, వాటర్ని ఇక్కడ సొల్యూషన్ హీట్ చేయడం వల్ల వాటర్ కూడా సేమ్ టెంపరేచర్ దగ్గరనే ఉంటాయి. సో ఆ టెంపరేచర్ వాటర్ని మళ్ళీ టెంపరేచర్ రెడ్యూస్ చేసుకోవడం కొరకు ఇక్కడ మళ్ళీ హీట్ అనేది మనకి బయటికి లాగుతూ ఉండాలి, అంటే కూలింగ్ మీడియం యూజ్ చేస్తూ ఉండాలి. సో లో టెంపరేచర్ దగ్గరనే వాటర్ హ్యావింగ్ ద హైయెస్ట్ ఎఫినిటీ టు అబ్జార్బ్ ద అమోనియా వేపర్స్. ఈ వాటర్ తక్కువ టెంపరేచర్ దగ్గర ఉన్నప్పుడే అమోనియాని అబ్జార్బ్ చేసుకోగలదు. సో అందువల్ల ఇక్కడ జనరేటర్ లో అప్లై చేసిన హీట్ మనం రిజెక్ట్ అయిపోవాలి, అంటే హీట్ మనం బయటికి లాగుతూ ఉంటాము బై యూజింగ్ వాటర్ యాజ్ ఎ కూలింగ్ మీడియం. ఓకే, కూలింగ్ మీడియం యూజ్ చేసుకొని హీట్ అబ్జార్బ్ చేస్తూ అబ్జార్బర్ లో టు మెయింటైన్ ద టెంపరేచర్, సర్టన్ టెంపరేచర్ మెయింటైన్ చేస్తుంటాం. దట్ ఈస్ ద అబ్జార్బర్ టెంపరేచర్. ఇక్కడ వాడే కూలింగ్ మీడియమే ఈ కండెన్సర్ లో కూడా వాడతాం కూలింగ్ మీడియం. ఇక్కడ కూడా హీట్ రిజెక్ట్ అయిపోవాలి. సో ద టెంపరేచర్ ఆఫ్ ద అబ్జార్బర్, టెంపరేచర్ ఆఫ్ ద కండెన్సర్ మెయింటైన్ ఎట్ సేమ్ లెవెల్. ఓకే, let us look the theory. In this VAR system, ammonia NH3 used as a refrigerant and water H2O used as an absorbent or absorber. Okay, absorbent ga use chestam dinni. The aqua ammonia means the ammonia mixture with water. Whenever the ammonia mixes with the water, that is called the aqua ammonia from the absorber. Aqua ammonia ante ikkada unna mixture from the absorber at low temperature, TA is the absorber temperature, is pumped into the generator. into the generator at a temperature Tg, generated maintained at a temperature Tg. The heat added in the generator, heat input to the generator, separates the ammonia vapors. It separates the ammonia vapors from the weak solution. So weak solution only ammonia separate అయిపోతుంది. That weak solution comes back to the absorber. The weak solution returns back to the absorber through the pressure reducing valve. The ammonia vapors condenses in the condenser at a temperature Tc. The temperature of condenser is Tc, that will be condensed in the condenser. The liquid ammonia is throttled to the evaporator. Throttle means it's passing through the throttling valve to the evaporator pressure.